Hey, it's Jillian. We're going to get started on polynomials now. So let's have first a review of the prerequisite skills we really need to have in order to be able to apply what we're learning in this chapter. For number one, evaluating expressions. Make the appropriate substitutions and then simplify using the order of operations, which you know is BEDMAS, right? Brackets, exponents, division, multiplication, addition and subtraction. So for example, when x is -2, y is 3, and z is -1, what's this equal to? So I'm just going to make a bracket for z and plug in z. And then for y is 3 minus 3x is -2. Okay, so this here is -1, and then in these brackets, let me make square brackets. It's probably better for you to see with that. You'll see in here that's 4 times 3 is 12, and then -3 times -2 is +6. Okay, so now we have -2 times 18, which equals -36. Let's try this one now. We have 2z squared, z is -1, minus 3y squared, y is 3, minus 4x squared, and x is -2. You'll see if you take the time to put in those brackets, leave them blank, and then pluck in, literally plug in what these values are, you're just set up all really nice and neat and clear, and it's easy to see what to do. So this is, we multiply or exponents first. Of course we do exponents first, so that's going to be -1 times -1 is +1, 3 times 9, and 4 times -2 squared is +4. Then we have 2 minus 27 minus 16, and then we have 2 minus 27 is -25 minus 16, and minus 25, and then another minus 16 is -41. Okay, now let's take a look at our exponent rules. So we know that when we're multiplying and bases are the same, whether we have variables or constants. So if we have 2 to the 3 times 2 to the 7, we know that's going to be 2 to the 10. Bases are the same, we multiply, so we add the exponents. Bases are the same, multiplying, we add the exponents. Same thing but with dividing and subtracting. When you have two terms that are the same base and you're dividing them, you subtract the exponents with the same base. So for example, if you had 3 to the 5 divided by 3 to the 2, which also could be written like this, of course, the whole thing is equal to 3 to the 3, or 5 minus 2. And then of course you can figure out what 2 to the power of 10 is and 3 to the power of 3, but I know you know that part. Alrighty, and then here, let me just put an arrow here and here. And then here we have something like this. So if we have 2 to the 3 to the 4, that's the same as 2 to the 3 times 4, which is 12. So here let's simplify using these exponent rules and express each answer in exponential form. So that means leave it like this. You don't need to simplify it and find out what 2 to the power of 10 actually equals to in a large number. So here, a couple things to remember. One is that in the past we've said that 1x is the same as x, and x to the 1 is the same as x, so 4 is the same as 4 to the 1. And we have bases the same and we're multiplying, so that's 4 to the power of 2 plus 3 plus 1, which equals 4 to the power of 6. Then here, we have y to the 5 divided by y to the 3, so y to the 5 minus 3 is equal to y to the 2. Here we have y to the 7 times 2, which is y to the 14. Here we have numbers, and then we have variables that are powers that have exponents. So we're going to, really what we need to do is I'm going to write it out. -2 times -4, and then we have y to the 3 plus 4. So what did I do? I took my numbers and I multiplied them. And then I also multiplied y to the power of that number, because it's multiplying, plus that number. So that whole thing equals negative 2 times negative 4 is positive 8, and this is y to the 7. So you can go from here to here in the future if you find this really straightforward. I just wanted to write all of this out, so if you are finding that you're stuck or you just didn't really even know how it all worked, that you would absolutely have the steps. So here we've got negative 10 divided by negative 2, so negative 10 divided by negative 2, and then we have m to the 7 minus 2. m, 7 divided, so it's subtract 2. So now I've got negative 10 over negative 2 is positive 5, m to the 5. And over here, I'm going to cube everything in here. So there's two things in here. There is negative 2 that we need to cube, and x cubed that we need to cube. So negative 2 times itself 3 times is negative 8, and x to the 3 cubed is x to the 3 times 3 is 9. Okay, so that's a little review on exponent rules. Now let's take a look at like terms and just collect our like terms. So what I like to do is I like to rewrite this, and I like to put a little sign or tick or underline or something underneath the like terms so it's easy for me to see them. So I go like this, and I write those two together. Then x and x, so plus 5x minus 2x, and then scoop on the integers, negative 7 plus 4, negative 7 plus 4. Then it's easy, you just do that, that, and that to simplify. So 1x squared and 3x squared is 4x squared plus 3x minus 3. You may find you can go straight from here to here, but I will tell you that as these questions get longer, you will find that you maybe forget something or make a silly mistake in your head, and if you just take 10 seconds and write this step out, you'll find that you almost never make a silly mistake. Another thing that's a good check is just counting. 1, 2, 3, 4, 5, 6. I had 6 terms, and when I rearranged them, I had 1, 2, 3, 4, 5, 6, so I saw I didn't miss anything. Okay, let's see here. So I've got negative t squared and negative t squared. Then I have these two, which is negative 4t and negative 5t. And then, oh, I also have this one, negative t. And then I just have 115 all on its own. So here I've got negative t and negative t squared, so that's negative 2t squared. Here I have minus 4t, minus 5t, and minus 1t. So that's minus 10t, and then the 15, there's nothing to collect. Alrighty, let's continue with our review of the prerequisite skills for this unit on polynomials. Here, expanding. So expanding, we know that means multiplying out the brackets, so I have to do x times this, x times that, and x times that. In fact, I have to just do x times everything in the brackets. There we go. And then here we're going to do minus 3a times a squared. And if you need to write this step, I didn't do it here, but let me just write this step here in case you need to. You can write out what you're doing. Minus 3a times 2a minus 3a times negative 1. Okay, so then I can do this, this, and this with the multiplying. So that's negative 3, a to the 1 and a to the 2. Is of course a to the 3. That's minus 6a squared. And that's minus times minus is plus 3a. Simplifying, so more expanding brackets and then collecting. So here we have 4 times 3a, 4 times positive 5b, minus 1, right, there's a minus 1 there, times 7a, minus minus b, and now I'm going to collect my like terms. So I've got 12a minus 7a is 5a, And 20b plus 1b is 21b. Again, if you need the middle step to rearrange and write it the way I did originally on the other side of this paper, go for it. If you find that it's unnecessary for you, there you go. Okay, let's see. You'll notice all my equal signs are in line. Good math grammar. So I have 6x plus 8x plus 12y minus 4z plus 5y. Okay, how many x's do I have? There they are. So I have 14x, my y's. I have 12y and 5y, that's 17y, and then one z term, nothing to collect with z's. Okay, let's keep going. Here I've got greatest common factor. So when I look at this number, or term, and I look at this one, what I want to know is there's two ways of looking at it. What can I divide evenly into both of these? What's the biggest, the greatest number I can divide into evenly, or greatest number and variables I can divide into both of them evenly. Another way of looking at it is breaking these down into their factors. So let's do this the division way, and let's do this into factors, just so you can see the two ways of looking at it. Actually, I don't need an equal sign there. So if I look at the dividing part, the dividing way, well, what number goes into 12 and 16, the highest number? Well, if you know your 6 times tables, you'll know it's 6. And then here, there's 3 x's here and there's 2 here, so we can divide x squared into both of these evenly, right? So just when you check with your eyes, and you can see 6 goes into 12 evenly, and x squared goes into that, those go into there. So the greatest common factor of these two terms is 6x squared. Now let's take a look at breaking down the factors. So here this is 3 times x times y times z. This is 3 times 3 times y times z. This is 2 times 2 times 3 times x times z. And then you look through and you see, what do they have in common? So they all have a 3. They all have a z. And that's all they have in common. So the greatest common factor is 3z. So again, you can do it either way, it doesn't matter, they both work. So let's take a look at this one. I'm going to do this one with factors, and I'll do this one with dividing. So here I've got 10 is 2 times 5 times r times 1t, 2t's, 3t's multiplied together. This is 3 times 5 times r times t, and this is 2 times 2 times 5 times 1, 2, 3 r's, and times 1, 2, 3, 4 t's. So let's see what's common. They don't all have a 2, they all have a 5, they all have 1 r, and they all have 1 t, they all have a second t, but they don't all have a third t. So what have I circled? 5rtt. 5rtt. And that's how you do that one. And then back over here, I'll do the dividing. So here I've got 9r squared, 18ab, and 27xy. So the variables are all different, so we're just going to look at the numbers. We know our 9 times table, 9 goes into there, 9 goes into there, and 9 goes into there evenly. So our greatest common factor is 9. And that's how you do that, and those are the skills that you really need to be excellent at in order for this unit to be able, for you to be able to learn the new stuff and then use your information from your new stuff that you've just learned, all of this stuff that you've learned previously, and put it together to solve the questions that you'll be given.